I'm sorry guys, like the previous video, the top of my iPad touched a book and it just got locked, and once it gets locked the recording stops. So I'm continuing from where I stopped in the previous video about section 4.1. I was introducing exponential functions and told you how to look at it and what do you mean by a number raised to the power of a square root of an irrational number, or sorry, a number raised to the power of an irrational number. So how do we solve it, how do we approximate things, and what do we exactly mean by that, right? So now I was on the way of defining exponential functions, and the video ended there, so I'll continue from there. So to define exponential functions, the exponential function with a base, I will write exponential functions as EF. So the exponential functions with base A is defined for all real numbers x, that is for all x belonging to R, by f of x is equal to a to the power of x. So where a is greater than 0 and a is not equal to 1. A is greater than 0 in the sense it can be 1 as well, so but we are avoiding 1 in this case. So you have to really understand why this restriction is required. Okay, so we assume that a is greater than 1 because the function f of x is equal to 1 over x is nothing but 1 itself. So this is just a constant function. Okay, so there is no difference, so there is no speciality of it being called as an exponential function. And this particular, when the base is 1, it adds up lots of complications to many definitions, as you have seen that in your quiz 1, where I had a problem that I had given to you, like check whether if the bases are same, will the powers will also be same or not. So that was like violating the condition when a was 1. So there are many properties in it, especially when it comes to exponents, where things hold for numbers which are greater than 1, but not for 1. Okay, so we avoid that because that is just an outclassed thing. Okay, so here are some exponential functions examples. So examples, f of x is like 5 to the power of 10. So where 5 is nothing but the base and 10 is an exponent, correct? So this we know that. And if we have f of x is equal to 2 over x, so here the base is 2, and you can express any number with using these bases, like base 2, base 3, and base 10. Okay, so we usually follow the base 10 method, but when it comes to binary numbers and there are certain number formats where we need to express things in terms of base 2 and base 3. So especially binary, which is very useful when it comes to studying electronics programming or computer science, like many programming languages when you study. So you will have to do things in binary format. So that is when we study exponential functions with base 2, and usually we follow the base 10 format. Okay, so let us see how do we evaluate exponential functions. I would like to do a problem for you, that is problem number 8 in your book, that is exercise problem number 8. So we have to use a calculator for this. You can do it, I'm doing it along with me. I do have a calculator by the side of me and I'm calculating, so you can do along with me as you watch this video. So the function is f of x is equal to 3 over x minus 1. Okay, and you are asked to evaluate all these values, f of half and f of 2.5 and f of -1 and f of 1 over 4. So f of half is nothing but it is nothing but f of 0.5, correct? So that is nothing but 3, okay, 3 over 0.5 minus 1, so that would be 3 over negative 0.5. That is nothing but 1 over 3.5. okay, so let me calculate what is 3.5. okay, you get it to be this to be equal to 1 over 1.732 and something. This is approximate, so 1 divided by the answer is nothing but approximately equal to 0.577 and so on, so that can be written as 0.58 or 0.578. so you can approximate it based on the same way. So then if we have f of 2.5, that would be 3 to the power of 2.5 minus 1, so that would give us 3 to the power of 1.5, correct? So 3 to the power of 1.5, I'm doing it using the calculator, so that would be approximately 5.197. okay, and you can check this. I'm doing it in the calculator by in my hand, like, yeah. And if of -1, so this is very simple. You don't need a calculator for this, do you? I don't think so. You need a calculator for this. Okay, so 3 to the power of -1 minus 1 is -2, so that is nothing but 1 over 3 square, so that is 1 divided by 9, so that will be approximately 0.111 and so on, 111, that recurs. okay, so yeah, one more thing I would like to tell, that all the rules and properties that were valid for the exponents, so the laws of exponents, they are still true when the exponents are real numbers. It is not necessary, like as I told you in the previous video while introducing exponential functions, we defined exponents in 1.6, I don't know, 1.2 or something. Yeah, we defined it to be where the power belonged to, like the power was a rational number, right? So now we are defining it to be a real number. That doesn't change any laws. So without telling you, I just applied all the laws in the problems above. Yeah, all the laws of exponents are valid. Whatever properties you learned in section 1, it's valid even when the power is a real number. okay, and the last one was f to the f of 1 over 4, so that would be f of 0.25. so this will be 3 to the power of 0.25 minus 1, so that will be 3 to the power of -75, that is 1 over 3 to the power of 0.75. so let me apply and see what do we get. Yeah, so we get this to be 1 over approximately 1 over 2.28. okay, so that would give us approximation of 0.439, okay, 86 something, so I approximated it to 9. okay, this is a very simple quiz problem. So quiz 1.1, so this would be, you will have to do problem number 10. so in the similar fashion, you need to use a calculator as the instruction says. So use the calculator and calculate the values of g of x, that is given function, and write the answers. So in the next video, I will end this video here. In the next video, we will learn how to graph exponential functions. We will see what are the techniques that we use to graph exponential functions, and find out what is the speciality of asymptotes in this particular kind of a function, and what I said, like the behavior of the function. For a very small change in the input, there will be a drastic change in the output. So we will see that whether that's valid, or that does that reflect on the graph or not. okay, So I will see you very soon with the graphing of exponential functions. Thank you for listening. Bye.